Good morning, good afternoon, and good evening to all of you, wherever you are. I am Ruchir Shastri, President of Softsys Hosting, an innovative cloud solutions provider, and I'm going to present today on how to achieve better efficiency by automating scaling and deployment process. We will also take a few examples of our ScalElastic cloud platform for demo purposes. Okay, so our agenda today is going to be understanding developers' efficiency. So we'll see how can developers improve their work efficiency. Second is evolution of cloud computing platforms. We'll see how cloud computing platforms have evolved over past years. Next, we'll head on to the automation in the process. We'll see how can automation help in streamlining and improving the efficiency. We'll also look over the containerized technology and how it can help. We will learn about a few advantages of containerized technology. We'll move on to deployment and automation. We'll see a few options of deployment and automating it with Git along with pre and post deployment tasks. We will look at automated scaling and see how it is easy to scale horizontally and vertically in an automated manner with customized rules. And lastly, we'll look at some of the sample use cases for the most common web scenarios. So how do we measure developers' efficiency? Developers are tasked with creating fast, intuitive, and user-friendly web apps that helps solve business problems. Hence, their efficiency is measured by quality and amount of development tasks that they perform. They should not be spending significant amount of time in system administration or server administration. However, the bitter truth is that they do spend hours and hours behind this. As per a report, 76% of developers spend as much as 25% of their daily time in addressing issues specific to cloud servers setup, which is not good and it needs to be fixed. So to address this, let's review what developers typically seek. They typically need an easy to use platform which just works flawlessly. They need a platform along with tools that help them to deploy that code onto the cloud with zero or minimal change. They need tools to quickly set up predefined environment with required components installed. Having security inbuilt is also greatly helpful for them. Lastly, they need a platform which has auto-scalable rules that can be set up so that cloud environment stays elastic based on the load. Let's see how cloud evolution has occurred historically. So this is a graphic representation. It all started with having a bare metal physical server. Then we moved on to the virtualization with various virtualization technologies evolving. Cloud computing followed with configuration management options, which allows more user control on the cloud. Service orchestration help in managing and automating tasks, and we are currently waiting for platform magic to happen. This can compare to a real-life example whereby we had a box full of Lego blocks, and we had to build structures from these blocks from scratch. Now, we have various pre-built structures available, and we just to hook them together to create a monument. In technical terms, we need to bring together stack, tools, and rules to customize entire environment based on our business objectives. So we need a full control over the environment. Let's look at the level of automation that is currently available. So the graphic representation here shows two different aspects. The process marked as before is the one that is traditionally followed. You start with the project, install required components, deploy your code or database, manually scale the environment to assumed correct levels. You never know whether the resources allocated to an environment are correct or whether they are high or low. Thereafter, you replicate onto different development, testing, staging, or production stack setups. All of that is done manually. And lastly, you update as required before you can enjoy. Now with advanced platform as a service, you can automate majority of the tasks. So essentially, you just start the project and enjoy. The platform takes care of the rest. Isn't it cool? So with advanced platform as a service, you can automate majority of the tasks. So how is this achieved? Having a ready-to-go product line with tools and stacks that can be deployed with a single click. Second, having a turnkey technology pack that helps you in automating tasks like deployment. There's also automation in scaling with advanced business extensions or rules that can be customized along with option to replicate environment in one click. And the end result is that the customer has complete control over all the above steps, which are again customizable, and hence it helps in addressing all customer challenges. Before we dive into more details, let's take a look at containers as they are key to this entire setup. Traditionally, with a virtual machine, you had a web database, API, and storage, everything onto one server. This doesn't help in efficiency or redundancy. Sure, you can have separate virtual machines for each of these services, but you also understand that each virtual machines require separate management in terms of security, operating system, patches and updates, and not to mention about the high costs that are involved with virtual machines. With containers, you can easily split all the services in individual containers without the overhead of managing it like virtual machines. And all of this is at significantly less cost. Let's see some of the advantages of containers over virtual machines now. Here's a graphical outline of setup of virtual machines and containers. Virtual machines run on hypervisors which require host operating system and underlying hardware. Each virtual machine is assigned virtual hardware and it has its own guest operating system. You thereafter have your apps and services installed in the guest operating system. When you compare this to containerized technology, it removes several layers from this traditional virtual machine setup. You have host operating system installed on hardware, which directly holds containers with your apps. This eliminates hypervisor, virtual hardware, and guest operating system that is required in virtual machine setup. Because of lower requirements of hardware and software resources, containerized technology helps to achieve higher density. That is, you can have more containers on the same hardware. You have better elasticity, so you have an option to easily scale without downtime. You have increased portability. You can quickly move containers. And lastly, it is advanced scalability. So you can automatically scale up and scale down. So let's see how containerization helps in more density. So it's a visual representation on how this eventually helps in more density and increased profitability. As you can see, we are taking an example of hardware node with 4 apps. With traditional virtual machine setup, you will have 4 virtual machines set up with set amount of resources. The colored section of VM blocks indicate actual usage of resources, and the white section indicates unused resources, which cannot be reused for other apps. When you compare this to the containerized setup, it has a very less footprint in terms of resource usage, and hence they utilize very small blocks of resources with all other blocks free for more apps. Hence, with containers, you can have more apps on same set of resources and without allowing the resources to go unused. And at the same time, you also do not pay for unused resources. Let's take a look at how we can scale and resize without downtime on containers. Virtual machines operate with its own guest operating system, and hence, whenever there is a change in resource, a guest operating system needs to be rebooted. Hence, when you want to upgrade resources or scale or downgrade resources, there will always be a downtime involved at each junction. Now, this entire scenario changes with containerized setup since there is no downtime involved during scaling. You can scale on the fly without any requirement of a reboot. So this helps in automating the entire scaling aspect. We'll now move into some of the popular deployment options. Developers require full control over deployment, and they prefer to do it using an option that they are most comfortable with. You should essentially look for a platform that provides all of these options. Like you can deploy using archive on your local machine through the dashboard, or just provide a URL and it will be auto-downloaded and deployed. You can also deploy from Git, SVN, Bitbucket, or from public and private hub registries. If you prefer to deploy from more specialized tools, plugins that support Eclipse, Intel, Java, NetBeans, Maven, etc. are also excellent to have. Hence, having a variety of deployment options helps in using deployment method that suits best for your business and without having your developers to relearn a new method. Here are a couple of screenshots showing archive deployment in our ScalElastic platform. As you can see, you can upload your archive from local machine or just provide a URL and then just click deploy to, which will auto deploy the entire project onto your environment. Next, we move on to deployment using Git or SVN. So as you can see in the screenshot, you can add your repo, you can enter the URL, branch, and click on deploy, which will automatically deploy your app into the environment. So that makes things extremely simple. Now this is a manually deployment method using Git and SVN. Next, we take a look at how we can automate this. Now you can add your project and select the option to auto deploy your app every X minutes. So here in the example on the screenshot, we are selecting 30 minutes, but this can be customized. So the platform will check for changes and automatically deploy the project whenever it is updated. So this eliminates the need to manually deploy your project. So this brings us to automation in deployment using an intelligent platform, which helps in automating your tasks and making your developers more free for performing their usual tasks of development. Now, many developers require more control on deployment with pre and post deployment hooks. So you can automate majority of your routine processes to get a ready-to-work application after deployment using pre and post deployment hooks. These are small sections of code that you can enter in your preferred scripting language, and those are executed either before deployment or after deployment. So some of the use cases of pre-deployed hooks are to check whether all the requirements are met for the application or the software, to pre-install any required software, to clear or prepare a dedicated folder for applications or files, or to lock data. Similarly, for post-deployment, the hooks can be used to either restart your application after deployment, to install project dependencies, to apply any other preferred customization, or to lock data. Now, one of the unique features of our ScalElastic platform that we'd like to discuss here is zero downtime deployment. And I must say it is loved by developers. So let's see how our platform helps in deploying your application without any downtime. We have a small graphic representation here. I hope all of you can see the small animation that's happening here. So as you can see, requests are coming in, request pool handles and routes the request. When a new version is deployed, a symlink is created which automatically points request to a new version folder. So this is demonstrated with the request pool changing from yellow to green and the symling turning from version X to version Y. So each time a new deployment process is executed, the corresponding apps files are duplicated and stored in a separate server directory, which is automatically named according to its creation date and time for easy identification. Then a special request redirector called symlink or a symbolic link. It switches between different apps, app versions after each update, pointing to the one that should be currently used. So you no longer need to schedule a large upgrade windows when you redeploy your application. And this entire process helps the deployment to stay nearly transparent to end users. Now move on to scaling part. Before we move to scaling, let's take a look at the Cloudlet, which is a bundled resource unit. So each Cloudlet is defined as 400 megahertz of CPU power and 128 MB of RAM. The resources of the nodes are measured in Cloudlet. We have kept this very small so that you have an option to increase or decrease resources in this smallest blocks and finally control your budget. So let's take a look at scaling options and how can that be automated. We first take a look at vertical scaling, which is increasing or decreasing the resources of a node based on the usage. In this example, you can see we have set a range of 16 cloudlets to 40 cloudlets for a particular Apache node. Hence, this node will start with 16 cloudlets of resources, and if it requires more resources, it will scale up to 40 cloudlets one at a time. When the resource usage goes down, it will automatically release the cloudlets one at a time until it reaches 16 cloudlets. So 16 cloudlets is the reserved space for the Apache node here. This is all automated. So the process of increasing and decreasing the number of cloudlets for the node is all automated based on the usage. And you can also see the estimated cost on the right, which is in this case is anywhere from 2.5 cents to 6.5 cents an hour. So essentially you set a range of resources for your nodes, and automation will help in scaling up or scaling down depending on the workload. We put this entire thing in a graphical representation here to see how a vertical scaling works. So you select reserved resources, which was 16 cloudlets in our earlier example, and then you set a maximum scaling limit. Your app will have this large white part demonstrated in the graph here as dynamic scaling range, where resources will be used as required. From pricing perspective, you will get discounted price for reserved resources, and then you always have an option to auto scale up to the maximum limit, and you just pay for what is used. Now let's move on to horizontal scaling, which is adding multiple nodes to an app. After you have set up vertical scaling with a range of resources that your app might need, you have an option to add multiple nodes or multiple instances of same config for additional computing power and memory. So you can just increase the number of nodes as per your requirement. This also helps in achieving redundancy and high availability for your application. We will review this in the next section. So this user interface provides with an option to increase or decrease the number of nodes for horizontal scaling. Just to summarize, vertical scaling is adding or removing resources from a node, whereas horizontal scaling is adding or removing nodes of an application. Now let's take a look at underlying node distribution. Now when you scale horizontally, that is when you add more number of nodes to an application, they are set up in a way to achieve high availability or redundancy for your environment. In this particular example here, You can see an environment with 2 MariaDB database nodes. There are 2 Nginx load balancing nodes, and there are 3 Tomcat web server nodes. Internally, each similar node is distributed on separate hardware. Hence, each of MariaDB nodes are on a separate hardware, and similarly, Nginx and Tomcat nodes are on separate hardware. So this helps in redundancy, as your environment will continue to stay online even if one of the underlying hardware node goes down for some reason. So this helps in business continuity and helps you achieve 100% uptime. Now let's take a look at how we can automate horizontal scaling. We reviewed how vertical scaling, we set a range there, and the system takes care of increasing or decreasing the resources. Now, if you want to automate addition of new nodes to the system, this can also be handled. So you have an option to create your own scaling rules depending on the load of your nodes to add additional nodes or remove existing nodes. Here's a test case with automated scaling turned on. The rules created here are for CPU consumption, whereby the platform will add one node to the environment if the load is more than 85% for 5 minutes of interval. So if if the platform sees high amount of load which is greater than 85% for at least 5 minutes, it will keep adding one node at a time till there are maximum 3 nodes. So these all parameters that you see here can be customized based on your use case. Similarly, when the load is less than 35 minutes for at least 10 minutes, you understand that the application has cooled down from a high traffic situation. The platform will remove one node at a time till there is a minimum one node remaining. That's a minimum to keep your application running. Now, as we have done this for CPU, you can also create rules for memory based on the amount of memory consumption. You can do this based on network consumption, that is amount of traffic that is going out or coming in. Then you have option to do this based on the disk IO or the disk IO piece as well. So you can set up your environment in a way that it scales up or scales down based on the load, and you do not lose sleep over your application becoming unavailable due to high load. So the platform automation takes care of this entire setup. In addition to having the option to receive email notifications when scaling happens, you can also review this from triggers history in dashboard to understand when are nodes added or removed from your environment through automated horizontal scaling. So you stay completely in the loop here. Now, all of this vertical and horizontal scaling also helps you in enjoying pricing advantages. So here's a comparison graph on how other cloud vendors are doing and how you can save with the pay-per-use model. So typically you pay for the limits assigned to your server with other cloud vendors. That is, irrespective of whether you use all resources or not, you pay a fixed cost. With a pay-per-use platform, this changes and you only pay for what you use. This graphical representation shows how much you can save with pay-per-use model without compromising on resource availability, since you always can burst or scale up to the maximum limit that your app may ever need. We have seen customers on this who have migrated from standard or a legacy virtual machine setup to the new pay-per-use model on our ScalElastic platform to be saving as much as 80% of their usual bills, because you have been paying for something that you have never used or will never be using. Now, when you decide to use a cloud platform, you need to ensure that you have proper support with offer of the technology and stack that you use so that you don't need to change it. Having option of multiple technologies helps immensely, and hence when you are deciding to move to a platform, you should ensure that it supports a variety of options like Java, PHP, Node.js, Node-RED, Golang, Tomcat, along with MariaDB, MySQL, MongoDB, etc. Since Docker and Kubernetes is becoming very popular, having native Docker Swarm and Kubernetes support is extremely desirable as well. In addition to having the option to install complex auto-scalable clusters, in one click is always helpful. Automated installation, scaling, replication, and updates simplify the management and support of applications requiring minimal to no involvement. These are some of the pre-packaged clusters that run out of the box, along with the possibility to package custom templates. So you can create one of your templates on this platform. So we'll look at some of these in a few use cases towards the end of this presentation. Now let's move on to security, which is the key these days. You never know what are the new evolving threats. So some of the security features that should be available in a cloud platform. The first one is network level security, which is the most basic and primary. So you should have control over the firewall, whereby you can create inbound and outbound rules to finally control network access to your environment. Most generally, just as a test case, you never need your database to have public access, or you want it to be limited to your office IP addresses only. So you can control all of this and much more with access to firewall. Second is encryption of data. Now you need all of your data to be encrypted with strong encryption algorithms to ensure that it is safe from hackers. This can be achieved with inbuilt either SSL support with the platform and also having encryption support at storage level. This ensures that all the data that is written on storage array is encrypted and non-human readable. Along with security, business continuity is also important. With a lot of dependency on cloud platforms, you need them to stay up and running at all times, because your business will come to a standstill when your cloud platform goes down. For this, your platform must have features of high availability to ensure that environment stays up even in case of hardware failure. As we saw earlier, this is available with the ScalElastic platform, with the way application nodes are distributed in different hardware nodes, and this allows your application to stay online even in case of a node failure. Now let's take a look at some of the complex clusters that can be deployed with a single click in ScalElastic platform. The first one is a very popular WordPress cluster. A typical WordPress setup includes just a web or the application server and database. This works perfectly fine for most cases, but if you need highly available WordPress or a very high traffic WordPress website, which needs to scale based on the amount of traffic, a WordPress cluster can help here. So as you can see, you can have a load balancer which will distribute traffic to multiple app servers. You can have an active passive database clusters. So your data is getting replicated across the different database nodes, and then a redundant storage array. The setup is infinitely scalable based on your load. So it will scale horizontally. It will add additional application servers if the web server load is high. It will add more database servers if database load is high, and then again come back to normal or the minimal or the reserved levels. The best part here is that you can install this entire setup with everything hooked together with just a single click on the green install button that you can see. The second one that we are looking at is the popular e-commerce platform Magento. So Magento, as you might be knowing, is a highly complex and resource-intensive platform which works best with various levels of caching. So you can deploy this with single click on ScalElastic platform, and the default topology is the one available on the right. There's a set of Varnish Nginx load balancers and Apache Web Server nodes which access shared storage. Most frequently accessed data can be stored on separate Memcache nodes. And the entire database setup is also auto-replicated setup for redundancy and high availability. This setup again can be scaled infinitely based on your app nodes for a particular level. And as we saw earlier, this you can install this entire complex setup with just a single click on install button, and your entire environment will be set up in around 5 to 10 minutes. Next, we look at pre-configured Kubernetes cluster. If you have ever been involved into setup of this, you must be knowing that it will take hours or days to get this set up, because it is highly complicated. But we again have this one-click option available for it. As you can see, you can select the number of workers that you need with auto discovery for each newly added node while scaling out. You can also set up custom Kubernetes cluster with special application deployed by default. You can provide your default stack YAML, and it will install it at the time of deployment. Now let's take a look at the database auto cluster. This is the most common scenario, as the database holds most critical data, and everyone needs a second copy of data to safeguard from data loss and also to ensure that their application stays up in case of any node failure. So you never want your application to go down when your database is down. So with this one-click database cluster deployment, you can select to have this entire cluster deployed as either a master slave with option to add extra slave. You can have master with option to have extra slaves again, or you can set up a single or multi-group replication as well. So this helps in efficient load balancing with proxy SQL, scalability, auto discovery, and automated failover. The same thing that we saw for a separate database cluster, it can also be used right at the time of environment creation. So if you want to deploy highly available database clusters integrated with the environment where you have either load balancers and Apache web servers or any other web servers, you will find the same auto clustering options when you select multiple nodes in horizontal scaling for database. So with this, you no longer need to spend hours and days behind these complex setups, as they work out of the box with just one click off, and they are all pre-tested and secure. Now, the platform should also support a routine DevOps operation, because those DevOps are the key to any business, or especially any IT business. So deploying separate environments for either the developers team or the QA team, along with staging and production process, is something very common. You have separate environment set up for each of the teams. Now it comes down for DevOps to spend hours setting up a replica of one setup for different teams. Now, with automated DevOps, you should have an option to clone your existing already pre-created environment, which will create an exact replica for different teams. And this entire process will be completed within around 5 to 10 minutes, whereby the earlier case developer was spending hours and hours behind setup of separate environments. It also has a collaboration feature with team members, so that multiple team members can work on the same environment easily. So these are some of the key things that you should consider to have in your platform that supports DevOps and automated deployment and scaling. So we are towards the end of this session today. Let's recap on what we reviewed today. The first was virtual machine versus containers, and how moving to containerized setup helps in automation, efficiency, and profitability. We also reviewed automated vertical and horizontal scaling to make our entire environment elastic. Deployment automation is extremely important to ensure that developers stay more efficient. Built-in platform security helps in keeping your cloud safe and secure from ever-emerging threats. Lastly, you enjoy cost saving by two ways. One is you save your DevOps very valuable time, and also with flexible pay-per-use pricing model. So thank you for joining this webinar. If you want to get in touch and learn more about ScalElastic Cloud Platform that supports all of these features that we discussed, you can email our dedicated ScalElastic team at scalastic@softsyshosting.com. You can also get more details about the product on our website, that is www.softsyshosting.com. In case you want to get in touch with me directly to discuss any use case or set up a one-on-one demo, my email address is ruchir@softsyshosting.com. So if there are any questions, I'll be happy to take that. Okay, so we have a few questions coming in. The first one is to know where are the data centers located. So we provide this platform can be deployed just about anywhere. So if you want this platform installed in your on-premise server, we can do that. If you want it in one of our data centers, so which are currently in Chicago, Denver, London, Singapore, Dubai, and Australia, we can do that. If you want this platform to be installed or set up on either AWS, Azure, or Google Cloud, we can do that as well. So the possibility is endless. You just demand and we can do that. So there's another question regarding how many customers we have. We have close to 160 customers using this platform. And yeah, those are the customers that are located right, who are using our data center for this purpose. We still have a few minutes, so in case you have any questions, feel free to ask and I'll be glad to answer. Okay, so it looks like there are no more questions. All right, then thanks a lot. And I'll be glad if you can provide your feedback for this webinar. If you have any questions that you would like to discuss with me personally, my direct email address is here, or our ScalElastic group dedicated email address is also here. Thank you all for joining in. I hope you have a good rest of your day or evening. Bye-bye.